hard at home, I'd probably leave a good page in a bit, all right? So, girls, remember your special triangles. Shh. Trig results. So, exercise 5.2, trig results. Just, I'm just going to go through it. You can write this down later. Now, you know that pi is 180, so you really need to know 45, 60 and 30 quite well. 45 is 180 divided by 4, because half of 180, like pi on 2 is 90 degrees, so pi on 4 will be half of pi on 2, will be 1 on root 2. So that's sine 45. So pi on 4 is 45 degrees, it's 1 on root 2. Cos 45 is now cos pi on 4. It's 1 on root 2. You'll notice in a lot of the HSC questions, they don't rarely get you to do it in degrees. You'll be asked to do things now in radians. Yes. I'd need to check. Oh, let me just pull it up. Okay. Pi equals 180 degrees. So therefore, pi on 2 is what? 90. Half of 90 is 45. Half of pi on 2 is pi on 4. Now, what's 30 in terms of, it's 180. See, that's 180 over 6. So it's pi on 6. Okay, what's 60 degrees? It's 180 on 3, which is pi on 3. I'm actually going to do some more. We're just going to keep playing around with this. So we've got, they're the ones you need to know. Pi on 2, pi on 4, pi on 6 is 180 on 6, it's 30. And pi on 3 is the same as 180 on 3, which is 60. Now, if I ask you for 2 pi on 3, this is how I do it. Right, this is how you look at this for people that are forgetting. You do not go 2 times 180 over 3. You go pi on 3, you know, is 60. That's the same as 2 lots of pi on 3, is it not? 2 pi on 3, 2/3. Isn't a third 2/3 1/3 plus another third in terms of fractions? So 2 pi on 3 is 2 lots of pi on 3. Isn't that 2 lots of 60? Which is 180. Not 180, 120. Now I'm off the page. So, what about 3 pi on 4? That's 3 lots of pi on 4. What's 1 lot of pi on 4? So these are the ones you need to know. Pi on 4, pi on 6, pi on 3. Once you know those, you can do everything else that's a combination of those. That's 3 lots of 45. That's how you do it in your head, which is 135. Then we've got 2 pi on 3. So we've done we've got pi on 4. We've done the quarters. A quarter, a half, 3/4. 1. We've got a third, 2/3, 1. We've got 1/6. What's 2/6? The same as? Isn't 2 pi on 6 just the same as pi on 3? So you don't need to know that one. Which is what? What's 3 pi on 6, by the way? Isn't that just pi on 2? What's 4 pi on 6? You could do this, if you don't like doing it that way, isn't it really just 4 lots of what? 4 lots, what's pi on 6? You can think of it like that. You can think 3 on 6 we know is a half. But 4 on 6, yes, we know it's 2/3, but you could say it's 4 lots of pi on 6. All right, 5 pi on 6 is 5 lots of pi on 6. Now, as long as you know that pi on 6 is 30, so it's 5 lots of 30, which is 150. You know the other way you can think of it, girls? What's 6 pi on 6? Pi. It's the full 180. So obviously 5/6 of pi is less than 180. Does that make sense? 4/6 of pi will be less than 180 because it's like 2/3 of pi. That's the other thing. It's 2/3 of 180. That's the other way you can look at it as. Are we okay with those? All right. You might have things like, we'll just keep going with those because they're good. What about 7 pi on 6. It depends now if it's sine cos tan. Yeah, so that's 7 times 30, which is 210. This is obviously a reflex angle by now. You know, 11 pi on 6. Tell me what it's almost. It's almost 12 pi on 6. It's almost 2 pi. So it's 360 degrees less how much? 30. That's how you can think of it. If you know that the pi on 6 is, so I wouldn't even go 11 lots of 30. Here you can do it two ways. You can go 11 lots of 30 is 330, or you can go it's 2 pi minus pi on 6. Do you get that? That it's really, 11 on 6 is 1 5/6. Do you get that? 11 on 6, the fraction, is 1 5/6, which is 2 minus 1/6. So it's really, it's 360 minus 30, 330. So these are ways you can do these in your head. All right, girls? I don't sit there with my calculator and go 11 times 180 on 6. Don't do it. I just know that pi on 6 is 30. You've got 11 lots of 30. Or you could say it's almost 2 pi because 12 pi on 6 is 2 pi. And you're almost there. You're short by 1 pi on 6. You're short 30 degrees from 360 degrees. Remember that 2 pi is 360. Okay, so girls, that's how I'd like you to look at those exact values. Combinations of 60, combinations of 30, combinations of 45. Just one more. What would be 7 pi on 4? Well, it's all. What would be 8 pi on 4? Yeah, 8 pi on 4 is 2 pi. This is 1 3/4 pi. 1 3/4. 1 3/4 is 2 minus a quarter. Do you get it? It's 2 pi minus a quarter pi. Because that's 1 3/4. 7 on 4 is 1 3/4. So it's 2 minus a quarter. Isn't that 360 minus 45, which is 315? Your other thing is to do 7 lots of 45, but really, I don't know what 7 lots of 45 are in my head. But I do know what 360 minus 45 is in my head. The other really common one is 3 pi on 2 is another really common one. That's 1 1/2 lots of pi. 3 on 2 is 1 1/2 lots of pi. That's 270. Okay, it's 1 1/2 lots of pi, or 1.5 times 180. It's 3/4 of the way around the circle. So let's draw. You okay with those? This is all on video. I'm going to draw them now. So do you remember our 4 quadrants? Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Oh, I need to move this up now. Where do we start counting our angles from? Positive ones.
0, 90.
Good. So I call this 0. Instead of writing 90, what do I write? Good. No. Yes. Next. Pi. Good. Next. 2 pi's over here. 1, so you've got a half, 1, 1 1/2, 2. 3 pi and 2. Excellent. And you know that pi and 4 would be in the middle, etc. Do you remember how we used to call quadrant 1 theta? What do we call quadrant 2? Remember it was 180 minus? Pi minus theta. Instead of 180 minus theta, it's now pi minus theta. Quadrant 3, instead of 180 plus, pi plus theta. These are our positive angles. Got to remember our negative ones in a minute. And instead of 360 minus theta, it's 2 pi minus theta. Do you remember those? Where theta is your acute angle. So we've got quadrant 1, 2, 3, 4. Girls, I'm just getting it straight from the book. I'm just putting our all stations to central in, girls. We start from here at 0, x-axis, and instead of, what's this one? minus 90, which is minus pi on 2, minus 90, minus 180, which is negative pi. What's this one? Minus 3 pi on 2, minus 2 pi. So these are the negative angles which travel clockwise. Positive angles go anti-clockwise. What do we call this? How do you get, for example, now I'm going to put these here. Remember we got our little butterfly? All right, how do you get to that line? Minus theta. How do you get to this line? And it's always got to have the theta in it. So minus 180, coming back in the positive direction. I've gone negative direction, minus pi plus theta. Girls, quadrant 3 is always plus theta, whether it be a positive angle or a negative one. It's minus 180 plus theta, because to get to that line and involve theta in the naming of the angle, you've got to go all the way to minus 180 and come back for plus theta. What about to get to that line? Minus 180 and keep going the same negative direction. What is it? 180 minus theta. Minus 180 to get to there and still going negative direction, minus theta. And how do I get to that last line there? I have to go all the way around. Minus 2 pi, coming back for a plus theta. So we've got quadrant 1, quadrant 2. Now there was an easy way that we learnt how to do these last year. All you do to the positive angles is subtract 2 theta from them. I'll just show you. Look at the, I'll put negative 2 pi there. Let's look at the positive angles. Positive angles and the negatives. And the quadrants. Quadrant 1, 2, 3, 4. What's the positive angle in quadrant 1? How do we name it? Theta. What about positive angle in quadrant 2? 180 minus? Quadrant 3? Quadrant 4? Alright, subtract 2 pi from each of those. What do you get here? Theta minus 2 pi or minus 2 pi plus theta. Take away 2 pi from this. What do you get? Pi minus 2 pi is minus pi. Take away 2 pi from this. See? Take away pi from this. So the difference between the positive and the negative angles is a minus 2 pi. So if you know these, you're just taking 2 pi away from them. But look, I do it by just going around the circle. That's the best way, instead of learning stuff off by heart. Minus 180 plus. Minus 180 minus. Because you're still going, if you're going this way, it's called minus. If you go this way, it's plus. So they're your negative angles. And the relationship between the negatives and the positives. I hope you got this over here. Now, we'll do some... Now, let's look at our all stations to central sort of stuff. So, in quadrant 1... No. Sine theta is cos tan. Just review. What have we got in quadrant 1? Sine is positive, cos is positive, tan is positive. In quadrant 2. But what do we call the angles in quadrant 2? Positive angles. In quadrant 2, I'll make a space. So in quadrant 2, they're called pi minus theta. Sine of pi minus theta equals, yeah, we know it's sine's positive, so it's just the same as sine theta. So we're learning, yep, cos of pi minus theta and tan, what do I write? Negative cos of the acute angle. Do you remember, once you get anything over 90 degrees, you can write it as an acute angle. Tan of 90 minus theta is, quadrant 2, minus tan theta. You know, because all stations to central, only sine is positive in quadrant 2. We're just learning to write them instead of 180 minus, we're writing them with the pi's. In quadrant 3, do you remember sine pi plus, cos pi plus, tan pi plus? I'll draw a nice little circle in the middle. Here we are. Do you remember the butterfly? You can always write anything in any quadrant in terms of that acute angle in the center. Think of your little butterfly wings. So, what's this one? All stations to central. Which one's positive here? So that will be tan of the acute angle. The rest are minus. Quadrant 4. All stations to central. And quadrant 4 is 2 pi minus. 2 pi minus. Cos, all stations to central. Only cos is the positive one. The other two are negative. Okay, so that's just doing them now with pi's and 2 pi's. Now we'll just do some examples. Oh, we're going to do, oh yeah. Ratios, cos and sine are complementary because sine means sin, sine is sine, cos means cosine. Difference between them are the letters co. So sine and cosine are complementary. Sec and cosec, you can see the difference between them is co. They're complementary. The other ones are tangent and cotangent. In other words, tan and cot. They're complementary ratios with the letters co. The other ratios are the reciprocal ratios, and they are cosec theta is 1 over which one, and how do you remember? It's the third letter. 1 over sine. Cot theta is 1 over the third letter. And sec theta is 1 over the third letter, cos. So the reciprocal ratios, which are cosec, cot, and sec, the way you remember them is the third letter of those reciprocal ratios, being S for sine, T for tan, C for cos. Asked about complementary ratios. 90 minus theta is the same as saying pi on 2 minus theta. How do you know which one to use? You look at how the question's given to you. If the question's given in radians, pi on 2, then you use radians. All right? If the question is a degrees question, you'll use degrees. You do what you'll know what to do because it'll be there for you. Sometimes if you're not comfortable with working with pi's, you can work in degrees and in your very last step change everything to pi's. You can do that. Okay? Based on question 2, find the exact value with rational denominators. Let's do G. Question 2G, just one example from each I'll do. Sec pi on 4 minus tan pi on 3. So find the exact value with a rational denominator. Sec pi on 4, which one's that? Sec 45. What's that mean? 1 over cos pi on 4. So girls, your sec, you can underline the third letter. You know that it's 1 on cos. So what's cos pi on 4? Cos 45, girls. Girls, in the first example, sec pi on 4 is 1 on cos pi on 4, and then minus tan pi on 3. This is the reciprocal of 1 on, because cos pi on 4 is 1 on root 2. It's the reciprocal or flip of 1 on root 2, which is root 2, and then we've got minus root 3 for tan pi on 3. Rational denominator, let's see what we get. What's cos pi on 6? Well, what's that? Cos of? All right. For those that are waiting. Then we'll go to question 11. All right, we ready? Cos 30. Cos 60. Sine 30. Sine 60. And there's no rationalizing the denominators. So we got root 3 on 4 plus root 3 on 4, which is 2 root 3 on 4, which is, yep, all right. Next, find the exact value of tan 7 pi on 6. Actually, I might change that one. I'm changing it to tan 10 pi on, so can I just change it to 5 pi on 3? Tan 5 pi on 3. Find the exact value of tan 5 pi on 3. Where's that one sitting? And then you can do exact value of cos 5 pi on 3 as well. Oh, no, maybe not. Make it 11 pi on 6. No, not that one. I'm trying to think. Find the exact value, sorry it's messy, of tan 5 pi on 3. Then I want you to find the exact value of cos 11 pi on... Yeah. 11 pi on 6. 5 pi on 3. Go. Oh, is it tan 300? Well, you know, you can think of it as tan... Isn't it 2 pi... What's the acute angle, girls? Isn't that really 2... Isn't that 1 and 2/3? 5 on 3 is 1 and 2/3. How do you get 1 and 2/3? You do 2 minus a third. So it's 2 minus pi on 3. So girls, that's quadrant 4. Is it not? Or yeah, so it's what? Negative tan 60. Look, if this is really bothering you, go straight to degrees, work it out, and do it. If this is really painful for you to do this, then I would just go tan 5 lots of 60 is tan 30, which is minus tan 60, and work it out. You're allowed to do that. Girls, shh, girls, don't do it like this if it's too confusing. No, you don't get marked down. The final answer, as long as it's correct, which is negative root 3. So you can do that. So I'm happy for you to say, well, it's 5 lots of 60. That's how I do it, which is tan 300, which is minus tan 60, because where is 300? It's over here with 60 degrees left over. Yes, you can do it. You've shown you know what the pi is by writing tan 300. So girls, you do not have to do this. If it's going to be too confusing, don't do this other thing, please. All right? Cos of 11 pi on 6. Yeah, it's cos of 330, because it's 11 lots of 30, which happens to be quadrant 4, 330 here. All stations to central, it's cos 30. Because, look, that little acute angle, your little butterfly, is 30. Equals root 3 on 2. Okay? Now, we're going to solve some equations. Find the exact value of sine 10 pi on 3. Now, how many times? You've got to work out what 10 pi on 3 is. You can just convert it to degrees. It's 3 1/3. 600? So it's the same as sine 600. So let's go around the circle. Isn't that going to be 360? Shouldn't we just go 600 minus 360? Do you know what I mean? It's the same as sine 240. Now draw where 240 is. 180, 240 is over here. I'm not interested. I just want this bit. So it's quadrant 3. So if that's, isn't that 60 in there? How do you get to 240? Like this. 180 plus the 60. So it's negative sine, what's inside the butterfly? Negative sine 60, which is negative root 3 on 2. Sine 30 is the nice one, it's a half. But now you've got that thing, you can look at your formula sheet. But look, that's only going to slow you down. It'd be great if you know them, but if you're not sure, check. You okay with this? Anything over 360, subtract 360? Okay, can I keep going? All right. I'll have to come. Let's solve some equations. Solve for 0 less than or equal to x less than or equal to 2 pi. Just question 13 type. I don't want to do exactly the same one. Oh, you've just got to give your answers in terms of, let's do sine of x equals, yeah, mine. This is mine. So solve for 0 less than or equal to x less than or equal to 2 pi. That's just the same as saying solve from 0 to 360. I'll give you the negative angles next lesson. Do you remember the steps? No. It's a normal x, it's fine. Acute angle, oh, what do we say? We do quadrants and acute angle. Remember, step 1, find the acute angle. Sine, don't worry about the negative, that tells you the quadrants. What quadrants are we in, by the way? Sine is negative. Quadrants 3 and 4, good. Acute angle, sine of what is root 3 on 2? Sine of 60. 60, I'm just going to write it also as pi on 3. So acute angle is 60 degrees, which equals pi on 3. Quadrants 3 and 4. Isn't quadrant 3 180 plus? Oh, you can even draw them, I don't mind. Quadrants 3 and 4 with 60 in there. 180, isn't it 240? But you've got to either know now that that's 8 lots of 30 or 4 lots of 60. Did I say it right? So how do you do that? Well, it is 180 plus, but can we start now doing it in? So therefore your answer is 180 is pi plus the 60 is that. Got it? We've got to start doing this now, girls. If you go all in degrees and can do another conversion, it's going to take too long. You know that 180 is pi. I've written the acute angle in terms of pi already. So isn't it 180 plus that angle? What's the other one?
2 pi.
360 minus that angle, and now all you do is deal with fractions. This is 1 plus a third. Look at the numbers in front of the pi's. 1 plus a third. What's that as an improper fraction? 1 plus a third is 1 1/3, which is 4 on 3. So it's 4 pi on 3. Girls, you do not go and write 240. You won't get the marks. And you don't go and write 300. So, because I've done 60 there and written that, you know it's 180 plus 360 minus. I'm sure you know that 180 is pi and 360 is 2 pi. Now you just do fractions. What's 2 minus a third? 1 2/3, which is 5 on 3. There you go. Do you want to do another one of those? Or you're okay? Right, next. An example from question 14, simplify something like the following. Sine pi plus theta. What does that mean? What quadrant? It's quadrant 3. That's sine 180 plus theta. So that's over here. How do you simplify that? Isn't it just also? It's, thank you. It's quadrant 3. It's negative. It's negative. And that, how do you get to 180 plus theta? You go 180 plus theta. That's what it looks like. Okay, so they're the types of things you've got in question 14. But there is another one I want you to do in that. I want you to simplify this. Sine of pi on 2 minus theta. Because this is not how you normally look at these. Actually, yes, you can simplify that. What does that mean? Sine 90 minus theta. You know it is something. Cos theta.
I don't get it. Wait.
Well, girls, we don't like to see the 90s in there. Actually, I'll give you an even better one. No, that'll do for now. You get harder ones next
What
time.
question is that? 14 what?
That's just an example of a 14 as well. It's not exactly the same as the ones there. I've just made up something similar. Okay, the rest, I will just leave it. How much time? No, according to, yeah, all right. All right, I'll set homework now.